Hello everyone, and welcome to week 2 examples. I hope you all had a good first week. I think we got through it fairly well. I'm going to provide some examples for this week's problems to cover the practice assignment and also the quiz that you'll have. Some of the concepts that are covered this week in the practice assignment will be some of the same concepts that we covered last week, so you may need to go back and view week 1 examples for help on those concepts, such as converting the fractions to mixed numbers and adding the fractions. So this week we'll get into a little bit of the order of operations. The order of operations tells us how the steps to take to simplify particular problems, expressions. And depending on what all we have in it, we would use parentheses first, and then simplify exponents, and then simplify multiplication or division. If we have both of those in the expression, we'll do whichever one comes first as we go left to right in the problem. And then addition and subtraction, same thing with that. If we have both of those in the problem, we'll do whichever one comes first as we go left to right. So this order helps us to make sure that everyone comes up with the same answers when we have different operations in a problem. So the first problem we're going to have is going to be to subtract the sum of 20.4 and 7.5 from 75.9. Now the key word here is sum. Sum means to add. So we need to add these two numbers and then subtract that total from 75.9. So I'm going to set that up as 75.9 minus 20.4 plus 7.5. So I'll add those two numbers first. And when I add 20.4 and 7.5, that gives me 27.9. Then I could subtract 75.9 minus 27.9. And when I subtract those two numbers, I come up with 48. So again, the key word there is sum, telling us that we needed to add it 20.4 and 7.5 before we subtracted the total from 75.9. Okay, find 8.2 times 25 minus 5.4 times 12. Now this deals a little bit with their order of operations. We have multiplication and subtraction within the problem. Our order of operations tells us that we must do the multiplication first and then do the subtraction. So I'm going to multiply those two groups there, 8.2 times 25 and 5.4 times 12. I'll multiply those two groups first, and then I will subtract their products. Okay, so 8.2 times 25 is 205. And 5.2 times 12 is 64.8. Now once I get those multiplied out, then I can subtract those two products for my final answer. And we come up with 140.2. So again, the key was to recognize that we had a multiplication and subtraction in the problem, but our order of operations tells us that we must do the multiplication first and then subtract. Okay. Alright, find the quotient. Key word in that is quotient. Quotient means the answer to a division problem. Find the quotient and remainder of 173 and the divisor 12. So that word divisor means that is the number that we are dividing by. So 173 divided by 12. And I'm going to set this up using long division. I know you all remember this. 12 into 173. Well, first of all, we look at 12 into 1. 12 will not go into 1. So next we add that other number in there, 7, and 12 will go into 17 one time. Then we take that 1, multiply it by 12, and bring that number down here. And then we subtract. So 17 minus 12 leaves us with 5. Then we bring down the next number. And we start the process all over again. 12 will go into 53 4 times without going over, because 4 times 12 is 48. Again, we subtract, and we come out with 5. Now in this particular problem it says to state the remainder, so we won't add any decimal places out here. When we get this 5 down here, we'll stop there. So my answer will be 14, because I had 14 total, and then a remainder of 5. 14 and a remainder of 5. Now this is similar to what we did when we converted to mixed numbers, except we didn't write remainder 5. When we converted to mixed numbers, we would have written this answer as 14, place the remainder up top, and then the 12 on bottom. 14 and 5/12. So this is similar to the same thing as converting to a mixed number. Okay. Alright, this is something that's a little bit different. Express 20 minutes as 1 1/4 hours. So first of all, let's change this 1 1/4 hours to minutes. Well, we know that 1 hour is the same thing as 60 minutes. Now 1/4 of an hour, to find that out, we would need to multiply 1/4 of times 60. Now the word of in multiplication also means, the word of in math, also means multiplication. So 1/4 of 60 would be the same thing as 1/4 times 60 over 1. And when we multiply top times top, we get 60. 4 times 1, bottom times bottom, we get 4. And 60 divided by 4 simplifies to be 15. So 1/4 of an hour is 15 minutes. Therefore, 1 1/4 of an hour would equal 60 minutes plus 15 minutes equals 75 minutes. Now that we've converted our 1 1/4 hour to minutes, we can compare the 20 minutes to the 75 minutes by placing those in fraction form. And we'll do that, like I said, by placing those in fraction form, 20 over 75, and then simplifying or reducing the fractions. I can divide both of those, the top and the bottom, by 5. That gives me 4 over 15. So that tells me that 20 minutes is 4 over 15 minutes expressed as 1 1/4 hours. So 4 over 15 would be our answer. Okay, so again, what we did, we converted the hours to minutes. 1 hour is 60 minutes. 1/4 of an hour is 15 minutes for a total of 75 minutes. And then we compared the 20 minutes to the 75 by writing those in fraction form, 20 over 75, and reducing the fraction. Okay. What is the product? Another key word here. Product. Product means to multiply, the answer to multiplication. What is the product of 12 over 17 and 4 over 3? Well, let's write that out. Now, to multiply fractions, we will multiply our top number times our other top number. So 12 times 4 gives us 48. And then our bottom number times our other bottom number. 7 times 3 is 21. And then we'll need to see if we can reduce this fraction. Now, one way to tell that 3 will go into a number is that if you can add the digits up and 3 will go into that answer, then 3 will go into the number also. For example, 4 plus 8 is 12, and we know 3 goes into 12, therefore 3 will also go into 48. Same thing down here, 2 plus 1 is 3, and we know 3 goes into 3, so therefore the little trick or rule says that 3 will also go into 21. Alright, so we can divide both of these by 3. 48 divided by 3 is 16. 21 divided by 3 is 7. Now, if the problem asks for a mixed number, then we'll convert that to a mixed number. And that will, oh, I'm sorry, I miswrote the problem. Let's go ahead and finish this out one, then we'll work the correct problem. That should have been a 17 down there. Convert that to a mixed number. That will be 2 and 2 sevens. 7 will go into 16 2 times with 2 left over. Now, for the correct problem, it should have been 12 over 17 times 4 over 3. So still we'll work it the same way. Top times top, and then bottom times bottom. 17 times 3 is 51. And again, I see that these two numbers are both divisible by 3, so I can divide those by 3. And I'll end up with 16 over 17. Okay? So you got a little bonus work there. All right. Quotient. Keyword quotient. Quotient means to divide, the answer to division. So when we divide fractions, you have to first rewrite the fractions as a multiplication problem. You always keep the first fraction the same, change your division to multiplication, and then write the reciprocal of the second fraction, or flip the second fraction. So you keep the first fraction the same, change to multiplication, and then flip the second fraction. And then from there you'll do what we just did on the slide before. We'll multiply the top number times the top number, and we'll multiply the bottom number times the bottom number. Again, I see that both of these numbers are divisible by 3. 21 divided by 3 is 7. 120 divided by 3 is 40. So 7 over 40 would be my final answer. So when you divide fractions, you keep the first fraction the same, change to multiplication, and flip the second fraction, and then multiply those out. Okay, converting a fraction to a decimal. Okay, to convert a fraction into a decimal, all you have to do is to divide. About like what we did on problem number 3. To write that as a division problem, we take the bottom number, place it on the outside of our division symbol, and take the top number and place it on the inside. Now I'm going to go ahead and add a decimal place there. And with that decimal place, we'll bring it straight up in our answer. We see that 8 will not go into 3, so I'm going to write a 0 there. Now to keep this problem going, I need to add a 0 after my decimal on the inside there, and then try dividing again. 8 will go into 30 3 times. Take the 3, multiply it times 8, subtract, and we're not asking for a remainder. We want to keep adding zeros until our problem comes out even. So we're going to add another 0 and we're going to bring it down. And then divide again. 8 will go into 60 7 times. 7 times 8 is 56. Subtract. Still didn't come out evenly, so let's try adding another 0. 8 will go into 40 5 times. 5 times 8 is 40. Came out with a remainder of 0. That's what we wanted. So 3/8 is equal to 3.75. 3.75. So the bottom number goes on the outside of the division bar. Top number goes on the inside. And you just keep adding zeros until you come out evenly. Or until you find a repeating pattern or something. Okay, I'm going to write the following fractions in increasing order. And this is similar to what we saw in week 1. We need to convert these fractions into, make them have common denominators so we can compare to see which one goes first, second, and third. Okay, so we have 11/36, 3/4, and 5/9. So the common multiple of 36, 4, and 9, the first number that all three of those will go into is 36. Okay, so we're going to leave the first fraction the same because it already had the denominator of 36. The second fraction did not. The second denominator had was 4. I had to multiply 4 times 9 to get 36, so I need to multiply the top number by 9 also. And that gives me 27/36. Okay. Third fraction, I had to multiply 9 times 4 to get 36, so I have to multiply 5 times 4 to get 20. So now I can see the order of these. That would be first 11/36, and then 20/36 or 5/9 would be second, and then 27/36 or 3/4 would be third. So 11/36, 5/9, and 3/4 would be the order from least to greatest, or increasing. Okay, so again, you have to get a common denominator to determine those. Okay, add these two numbers. So we're going to add these two mixed numbers. They already have a common denominator. So when I add the fractions, since they already have a common denominator, I can say 5 plus 3 is 8. When I add these two, I can say 6 plus 5 is 11. Now, 8/7 is an improper fraction, and we can't leave an improper fraction within a mixed number. So if I change 8/7 to a mixed number, 7 will go into 8 one time with 1 left over. 8/7 is the same thing as 1 1/7. So what I would have to do to write this correctly is to add the 1 1/7 to the whole number of 11, because 8/7 is 1 1/7, which would then give me 12 1/7. So we can't leave a mixed number or improper fraction within a mixed number. So we would have to change that improper fraction into a mixed number and then add it to the whole number that was already there. Okay. All right, multiply 5 3/4 times 8. All right, we don't multiply by mixed numbers. So the first thing we would have to do is change that 5 3/4 into an improper fraction. So we would say 4 times 5 is 20, plus 3 is 23. So 23/4 times 8, and we can make 8 into a fraction by placing it over 1. 8/1. Okay. Then we will multiply those Top times top, 23 times 8 gives us 204. Bottom times bottom, 4 times 1 gives us 4. Now see that both of these are even numbers, so I know they can be reduced, or both can be divided by 2. If I divide both of those by 2, that'll give me 1 over 2 over 2. I still have two even numbers, so they still need to be reduced again. So I can divide them by 2 again. And that will give me 51 over 1, or just 51. Now some of you may have seen that instead of dividing by 2 and then dividing by 2, I could have simply divided 204 by 4 and come out with 51. Okay, so the point is, make sure you get it reduced to the simplest form. Again, you have to change these to improper fractions before you multiply. Same thing with division, because remember, with division of fractions we have to rewrite them as multiplication. So the same rules apply. I have to change this to an improper fraction first. So that will give me 12 over 1 divided by 4 times 3 is 20. 4 times 5 is 20, plus 3 is 23. But in order to divide fractions, remember, we keep the first fraction the same, change to multiplication, and flip the second fraction. Then we would multiply that out. 12 times 4 is 48. 1 times 23 is 23. And we can change that to a mixed number. We know 23 will go into 48 2 times, with 2 left over. Okay. Alrighty. Convert 2.75 into a fraction. Now, your place value that we did in week 1 will be very helpful in this. You look for the last place value after the decimal point. So 7.5, we're looking for the place value of the 5. Tenths, hundredths. That's in the hundredths place. So to write this as a fraction, since that's in the hundredths place, we would take 275 and write it over 100. And then you would simplify the fraction. The 100 is there because the last number was in the hundredths place. Then you would simplify the fraction. We could divide both of those. I can see real quickly. We can divide each one of those by 5. 275 divided by 5 is 55. 100 divided by 5 is 20. Again, we could divide both of those by 5. So we come out with 11 over 4. Or as a mixed number, that'll be 2 3/4. Okay, so the key is finding the last number, last digit, the place value of the last digit, and you'll take that whole number without the decimal and put it over whatever number it is. So if my last digit would have been in the thousandths place, I would have taken this whole number and placed it over 1,000. And then simplify it. Okay, divide 27.51 by 0.03. Now the key here is that we don't divide by decimals when we do long division. So when I'm setting this up, the first thing I have to do is make this number on the outside into a whole number by moving my decimal over until it can't go any farther over to the right. So I'm going to move it 2 places there, just after the 3. Now again, this is kind of like fractions. Whatever you do in one place, you have to do in the other place. So if I move my decimal over 2 places here on the outside, I have to move it over the same amount of times on the inside. So 2 places. And then I can rewrite that as 3 going into 2751. Then it's simple division from there. 3 will go into 27 9 times. 9 times 3 is 27. That's 0. Bring down your 5. 3 will go into 5 one time. 1 times 3 is 3. Subtract 2. Bring down your last number, which is a 1. And 3 will go into 21 7 times. 7 times 3 is 21. Subtract. Don't have a remainder. So my answer when I divide those two would be 917. Okay, I hope you found those examples to be helpful. Again, they should be helpful to you not only in your practice exercises but also in your quiz that you'll have to take at the end of the week. Be sure to read over the online lectures and look at the examples in the textbook, and be sure to find any helpful videos through other websites covering these particular topics. Alright, everyone have a great week too, and I look forward to seeing some very good grades this week.